Hey RPS 3rd graders, Miss Tricky here for another performance task of the week. It is week 10 and all week long you have been learning about patterns. So let's go ahead and dive into a quick review. As you know, as 3rd graders, we study about two kinds of patterns, repeating patterns and growing patterns. For our repeating patterns, we most often see this in the numeric form and the geometric form. Numeric referring, of course, to repeating digits. So we can see here we have the pattern 135, 135, 135. And you can tell that the 135 is the core of that repeating pattern because we see that same set repeat over and over and over again, and it would continue on and on forever. For the geometric pattern, those have to do with shapes. So we can see that our geometric pattern has a rectangle, an arrow pointing to the right, an arrow pointing down, another rectangle, and an arrow pointing up. That ends up repeating again. So those first 5 of our polygons, those form the core. So once again, just like the numeric, they repeat over and over and over and over again. Then we have growing patterns. For growing patterns, these patterns, just like repeating, tend to be numeric, featuring digits, or geometric, featuring shapes. And these patterns follow a rule. So from this rule, they can either often have to do with operations. In 3rd grade, we see subtraction and addition as part of our rule, or for geometric growing patterns, we often see the number of shapes growing or shrinking. So let's take a look at these examples. For the numeric pattern, we see 20, 18, 16, 14. Can anybody figure out what the rule is for this pattern? Yeah, you're right. It is -2. So let's look at the geometric pattern. So you can see that we have some quadrilaterals, and the starting is one of the diamond shapes and one square. And then the next set is 2 diamonds and 2 squares, and then it continues to grow. What's going to be next? 3 diamonds, 3 squares, and then it'll probably be 4 diamonds, 4 squares. So our rule would be add 1 quadrilateral from each quadrilateral type each time. So now let's talk about our I can statement. Today, you are going to extend a growing pattern using objects. Your materials, as always, include your device, what you're viewing this video on, your creative minds, something to write on, whether that is your computer, your tablet, or your phone, or a piece of paper, and something to write with, whether that is the keyboard or a pencil or a pen. Before we get started, I was trying to think of a real-life example having to do with patterns, and I actually started thinking about a house. I was thinking about that because of the core, and my brain was thinking about like the basement or the foundation. So as you saw with both of our pattern types, there is always going to be the main step. That is the first part, and it does not change. For our repeating patterns, the core just goes on and on and on. But for our growing patterns, that very first step is always going to exist as that foundation, that starting point. So I was even thinking for the growing pattern of stairs. So as you can see from these brick stairs, the very bottom layer, that is like our first step for our growing pattern. And every single time that the stair maker built another level, they actually subtracted 1 set of bricks. So if you look at this brick design, you can see as you grow this pattern, there is 1 less set of bricks every time as you go. So that's just a real world example that I was thinking about. So now let's talk about the situation. So I was actually using line segments to build shapes earlier. And as I built these shapes, I realized that I was also building a growing pattern. Now I need your help to extend the growing pattern. And I believe that you can absolutely do it. So let's look at today's task. I'm going to switch over to our slides. As always, before you get started, hit the File button and hit the Make a Copy button. And go ahead and hit Entire Presentation so you get both pages. Click on the Folder button and make sure you go back to your own file. A great place to save this would be My Drive. Hit Select and OK. And it is going to make my very own copy of that presentation so that I can edit. So, as you know, any gray box, you can actually double tap it and you can type directly into it. So I'm going to go ahead and type my name and the date, 6/12, the last day of school for the 2019-2020 school year. I'm going to use the magnifying glass to zoom in a little bit so we can read it a little clearer. Let me go ahead and read over the directions for you. So this performance task today is called 7 squares. So you are going to use line segments to extend the square sequence below. So this is the one that I was building earlier. And the questions you are going to answer are, how many line segments would you need to show 7 squares? 10 squares? Describe the change that occurs each time a square is added. Use words, symbols, and pictures to explain your thinking. So, if you wanted to use the computer to solve this problem, you can go over to the line button like we went over last week and used. If you click it, you can actually add a line segment each time. So you'll just keep clicking that button and adding a line segment, and you'll be building more squares. Now, I don't want to do this problem for you, so I'm going to leave it at that. But what you can do is use this white space right here to continue to build squares. And if you would like to explain using words, you can type your explanation into this box below. The other suggestion that I have for you, in case you want to use some real-life manipulatives or objects, is you can use things that you find around the house. I was thinking things like toothpicks or maybe even cotton swabs, the kind that I use to clean my ear. Those would be great stand-ins for line segments. If you end up using objects around your house, please film yourself using them and giving your explanation for this task on Flipgrid, because I would love to see your creativity. Next, when you finish this problem, on page 2 we have an extension activity. So this extension activity reads, make an input-output table based on the 7 squares problem. As I went over earlier when we were reviewing the types of patterns, for growing patterns always follow a rule. So you'll type your rule right into this box. And then you will label the data in your input-output chart. We can see that in this row, in this column, we have number of squares. In this column, we have number of line segments. So, as all input-output charts work, whatever you put in here is then affected by your rule, and it leads to your output right here. So when you finish your problem, you are going to go ahead and post your solution on the Flipgrid. So go ahead and pause your video right here so you can scan this Flipgrid. Alternatively, click the link in the learning plan for today. Here is the RPS 3rd grade distance learning Flipgrid. If this is what you see, you are on the right page. You can see it's week 10 performance task, and I have a really cool GIF of a growing pattern that just does not seem to end. It keeps growing and growing and growing and growing. And I've just copied the same questions from the performance task right here. But basically what you are going to do on this Flipgrid is show off your squares and answer the following questions. There's a link to the performance task right here, also in your learning plan. And you'll click this button right here, this big green button with the plus sign, to record your video. I'm really looking forward to seeing what you do.
Welcome back to day 2. We're continuing to talk about the moon, its phases, and tides.